Give the equations of any vertical, horizontal, or oblique asymptotes for the graph of the rational function. Here's our rational function, so let's take a look at that. So we have f of x, which is equal to x squared minus 3x minus 4 divided by 2x squared minus x minus 21. So the first thing we want to do is we want to determine what if there are any vertical asymptotes. Okay, so let's go over some of the definitions here of a vertical asymptote. Now, a vertical asymptote occurs for every number that causes the denominator of the function to have a value of 0. So you should set the denominator equal to 0 to determine where vertical asymptotes will occur. So we can see that the denominator in the problem is 2x squared minus x minus 21. Okay, and we're going to set that equal to 0. Now, we can't solve it yet, so therefore we're going to have to factor this. So we can factor this by first checking if we can use the AC method here. So recall that the AC method, the value of A is 2, and the value of C is negative 21. And so 2 times negative 21 is negative 42. Okay, now in step 2, we're going to create our x before we factor, so we have negative 42, and then the value of b is negative 1. So what two numbers can you multiply to get negative 42? Then when you add them together, it gives you negative 1. Well, that's positive 6 and then negative 7. And so therefore, now we're going to write the first term. We have 2x squared, and then this is plus 6x, and that's minus 7x, and then minus 21. So now we have 4 terms. Now we're going to factor by grouping. So what can we factor out of the first 2 terms? We can factor out of 2x, and then what's left is x plus 3. And then we should get the same thing over here. And then we just need to say, okay, well, what I need to multiply it by x to get negative 7x? Well, that's minus 7. And therefore, this factors to be x plus 3 times 2x minus 7. So now that we know the factored form, we're going to bring it back over here. So now we know that this is x plus 3 times 2x minus 7. Okay, now we're going to solve both of those for x, and those are going to be our vertical asymptotes. So we're going to let x plus 3 equals 0, or 2x minus 7 equals 0. On the left side, if we subtract 3 to both sides, we're going to get x equals negative 3. And over here, on the right side, if we add 7 to both sides, we get 2x, which is equal to 7. Divide both sides by 2, and then x equals 7 over 2. So therefore, these are the vertical asymptotes, or at least where it's going to tell us, it's going to give us a 0 in a denominator. So we have negative 3 and 7 over 2. So let's go ahead and put that in there. So negative 3 comma 7 divided by 2. Let's check. And therefore, those are our vertical asymptotes. Okay, the next step is they want us to determine if there are horizontal asymptotes. Well, let's go ahead and check the definition here. So it says, there's a couple options here. So you take a look at the first one here, B. It says, if the numerator has a lesser degree than the denominator, then there is a horizontal asymptote at y equals 0, the x-axis. So let's take a look at the degree of the numerator. The degree of the numerator is 2, and the degree of the denominator is 2. So it doesn't apply for B, so we're not going to use B. Okay, now let's move on to C. It says if the numerator and denominator have the same degree, and the function is of the form of this divided by this, then the horizontal asymptote has the equation y equals a divided by b, which is the leading coefficient of the numerator divided by the leading coefficient of the denominator. So again, let's just go ahead and verify this. All right, so we see that what? If the numerator and denominator have the same degree, they do have the same degree. And now it says the horizontal asymptote is going to be y equals a over b, which is the leading coefficient of the numerator. Well, what is the leading coefficient of the numerator? Well, the leading coefficient of the numerator is a 1. So therefore, we know that the leading coefficient is a 1 of the numerator, and the leading coefficient of the denominator is 2. So let's go ahead and then write down what our horizontal asymptote is. So y is going to equal 1 over 2, and that's going to represent the horizontal asymptote. So let's go ahead and put that in there. So we have a horizontal asymptote, and that is y equals 1 divided by 2. Let's check our answer, and there is our result. Now it says select the correct choice below regarding the oblique asymptote. Okay, now let's take a look at the definition. It says if the numerator is of degree exactly 1 more than the denominator. Well, we know that we already applied C, so therefore we would say that D does not apply. So there's no oblique asymptote for this rational function. So let's go ahead and answer that. So we would say that there is no oblique asymptote. Okay, now that we've answered this question, let's just verify this on the graph so that it makes sense as far as what we just solved. Okay, so I'm opening up Desmos and I'm going to put this rational function in. So I have parentheses, I have x, and that's squared minus 3x minus 4. And then I'm going to divide that by 2x squared minus x minus 21. Okay, so I want you to notice here that this is what our graph looks like. Okay, so before we do that, now that we have our graph, now let's put in the vertical asymptotes. Well, the first vertical asymptote is x equals -3. And you can see here it creates a vertical line here because it's undefined. So this graph does not cross. So on the left side, this graph increases, never crosses that vertical asymptote, and it starts over here. So there's the vertical asymptote at where it's undefined. Okay, let's put in the other one, which is x equals 7 divided by 2, and you can see it's on this side over here. 7 divided by 2 is 3.5, and then we know that -3 is here. Now we got to put in the horizontal asymptotes. The horizontal asymptote is where is equal to 1/2. So y equals 1 divided by 2. Well, you can see here that it grows across here. So there is the horizontal asymptote. So the horizontal asymptote applies to this part here and this part here, and therefore you can see where the horizontal asymptote is. And that confirms our solution.